Well, welcome to another version of TechTime. Today I'm going to start talking about some static pressure in the part one. All right, if you got any questions, you're welcome to email them to us. Give us a call on tech support. I'm glad to help you out. Today I am Jim Strandlund, part of the technical services team. You can see some phone numbers there that you can get a hold of our guys. We're hosted by Intertech University and Intertech Energy Technology. Our websites are there. Please review them if you got any questions or concerns. Let us know. Welcome you to our broadcast. As you can see here, some of our service team members. Remember, you can all reach us at 618-664-5860 and give us a call if you need some help. That's what we're here for. All of our YouTube, our Intertech trainings, our tech times are all stored on our YouTube channel, Intertech University. Go on to the playlists. You can see the different playlists that we have, webinars, trainings, and our tech times are there. And all of them are listed. You're welcome to watch them at your convenience. So again, thank you for watching this. I want to talk a little bit about some of these topics today. Part two, I'm going to do next month. I'm going to start showing some cool examples for everybody to watch. But what is static pressure? Why is it important in regards to geothermal system design? Does plenum size make a difference? What is offset takeoff and why is that important? I'll talk a little bit about duct calculators and why, who needs it? So let's get rolling. What is static pressure in a ductwork system? Well, it's defined as the resistance to airflow in your ductwork. The scientific definition of static pressure in HVAC is that it is a force or pressure that is exerted in all directions evenly. The pressure is created from resistance and airflow when air is forced through the system. When a system has more restrictions, the pressure will be higher, and when there are fewer restrictions, the pressure will be lower. I found an interesting quote I wanted to share also. The CFM of a motor is directly rated to the external static pressure. The higher the external static pressure, the lower CFM you're going to get. The lower the external pressure, the higher the CFM. So high ESP readings indicate that there is excessive resistance in the system. Could this be caused by dirty filters, dirty evaporator coil? How about closed dampers? Restricted supply or return drills, or undersized ductwork. You can determine CFM if you know the external static pressure by looking at manufacturers' manuals, and there's details information in there. External static pressure is a measurement of all resistance of the duct system that the fan has to work against. Again, examples: filters, grills, AC coils, the ductwork. It is the sum of the suction pressure, negative, and discharge pressure, the positive, created by the equipment blower. So why does static pressure matter? Well, static pressure can wreak havoc on any HVAC system as well as our geothermal systems because it causes fans and blowers to work harder than they need to. It also increases the likelihood of coil freezing and compressor failure due to excessive workloads. If you notice increased noise coming from the system, that may be a good sign that there's high static pressure, and that could need to be corrected. Again, also, this will affect your airflow reaching the farther duct registers away from your heating system. Also, when you have a zoning system, there could be a malfunction in here as well. Let's say we got a damper closed or something that's not opening that can create this. One important thing to when you're designing some of your dampering systems or zoning is bypass dampers. Take a look at all your airflow going into each branch and make sure that your blower can handle it and is not under excessive loads. Here's a neat diagram that I found online, kind of showing you where people to take some measurements. So as you can see, the total external static pressure is the measurement of everything in the system from one end to the other. And so we're talking about how you subtract these ones from the other pressure to give you your total external static pressure. This is an important feature to learn and to be used as a good diagnostic tool. So here's another picture of a diagram of more like a gas furnace. Same kind of a scenario. You can see where you can take some measurements and how you end up coming with your external static pressure. So lots of different tools and stuff out there today that you can do your measuring with. These long silver pieces here are called pitot tubes, and that's important imperative to put into your ductwork to get a proper reading in the duct. So make sure you have some of this type of equipment with you to do this diagnostic. In the original tool, everybody's heard of the magnet helix gauge. This is what has been an industry standard for years and years, and they got different inches of water column that you can get in these gauges. But again, make sure you get the kit with the pitot tubes, and they have the hose kit with them, so you can measure real accurately. What's the importance of a ductilator? Well, as you know, sizing and designing the ductwork for airflow, CFM is really critical. This is one that Intertech used to have, had from many years ago, that you can actually use. They actually recommend ductwork design of a 0.10 static pressure, but in my career, and I think a lot of people look at, we like to do designing ductwork on a static pressure of say 0.12 in the supply, and then we'll go to a 0.08 in the return. One thing that I always did and people do is I only try to design a system between 75 to 100 CFM of airflow coming out each register. That makes systems quieter. Costs a little bit more money, a little bit more material, but you can tout yourself as doing it as a better value to your consumer. So one of the things I used to do was a 5-ton system, let's say, had 2,000 CFM airflow. So I put in 20, make sure I had 20 registers if it was a non-zoned dampered system. And keep your customers happy, eliminate some of the noise. In your manuals, which is kind of interesting, maybe a lot of people don't realize and don't read your manuals, but we have listings here for maximum external static pressure. Now this is for an ECM fan. Now the ECM fans are designed to maintain a certain amount of CFM, and they can ramp up and slow down accordingly to duct. But if you make that thing run faster because of high static pressure, more electrical operation is consumed versus doing it the right way. Same type of a unit, but this happens to be a permanent split capacitor fan motor. Notice that the static pressure shown in here, how the static pressure changes the actual CFM of the piece of equipment. So this is why static pressure is important into your design. So look in your manuals, they should have some data like this in here, and make sure you're getting the proper CFM required by the manufacturer specifications. We want to make sure our heat pumps are reliable and have a great longevity. So, and okay. So have a couple of diagrams that were drawn up on some ductwork systems. To give you a couple of examples, I wanted to talk about starting collars. Okay, this particular appliance piece here is called an offset starting collar. Notice how it has a larger intake as is going out to the trunk line, and I'll show you some of the reasons why this is important in a minute. But one thing that a lot of people do here is they make your plenum the same size as the cabinet, and it's not the best way to do it, especially with ECM blower motors. So this should always be maintained at least a 12-inch or more, close to the blower opening size, and then transition to your plenum a lot bigger. This is very important on the operation of ECM fan motors. So at your convenience, you can expand on these, make them larger, and see. Got some suggestions here for some of these units that we have, a couple different design ideas. So take a look at them and get some ideas. Now, what I find is important, what I wanted to show, and this is part of where did she go? This is part of a ductilator that I have that shows all the back design of some of the duct fittings. What's important to know is look at the equivalent length of feet of some of the starting collars. So right here, you will see an offset starting collar. They're talking about an equivalent of 10 feet of ductwork. All right, if you do the straight stab in, this is equivalent to 35 feet of ductwork. So there's the importance of showing how some of these offset starting collars are when you're designing your ductwork. So keep in mind, this is something important. I wanted to expand it a little bit bigger and show it in a bigger piece. 10 feet equivalent duct with this starting collar, 35 feet of equivalent duct with this starting collar. So obviously the length of ductwork is a big factor in external static pressure. And so keep that in mind, use the proper takeoffs to make sure things are working good. I downloaded or I should say, got you a link here for a really good video for watching how to use a ductilator. It's put out by Micrometal Corporation, the same people that I have this information from. So at your convenience, if you want to learn more about ductilators, take a look, download this website address, plug it in. It's like a 6-minute video, something good for you to watch. So with that, this is what I have for this week, and appreciate that you attending. Please visit our Intertech University, get signed up for future trainings, look at the recordings. If you have any questions, please submit them to technical services at intertechgeo.com. Hope you all guys have a really good day. Thank you.